When we need a Java data structure, we should often start by asking ourselves if a simple array is sufficient. As the simplest data structure available to us, if we can write our program easily and neatly using just an array, that might be our best option to keep our program simple by extension. If you're writing code that must run absolutely as fast and memory efficiently as possible, arrays also have very little overhead. But in today's development world, where memory efficiency and speed really aren't concerns for your average program, which is going to run just memory efficient and speedily enough, sometimes we want to employ data structures with more built-in functionality, or maybe which are designed for a specific purpose. A data structure with additional functionality is the array list. One of the weaknesses of traditional arrays is that when we instantiate them, we have to give them a specific length. So we have to know how large we want our array to be. An array list is basically an array wrapped in some additional code that causes the array to increase or decrease in size to always be the size of the number of elements it contains. To see this in action, let's write a program that would actually be a little more difficult to write if we just used a standard array instead of an array list. We're going to want to begin by importing java.util. That's because java.util is where the scanner class, which will need to get user input, and the ArrayList class itself lives. Once we've declared a scanner, which we'll utilize some more later, it's time for us to declare our array list. Simply declaring an array list looks a lot like declaring any other object. We say what type of object we'd like to create, we give it a name, we use the new keyword because Java is going to have to set aside some memory to create this object since it's not a primitive. And then we tell Java to actually create the object. Even though we're not going to provide any arguments for our array list creation, we still need to follow it with the double parentheses. This is actually valid code that we've just written. But generally, when you create an array list, you're going to do a little bit more. The array list memory that we've created right here will actually store any single entity we place within it. That might sound really great at first, but honestly, it's not a good thing to have in our program. It's really easy to get confused if we have array lists or any data structure really that's storing just about anything. And if we feel the need to do that, we're either doing something really complicated or more likely, we're not writing our code as cleanly as we should. Maybe more importantly, once we store an anything in our array list, it's very possible for us to sneak by our compiler and create code that compiles okay but breaks at runtime, causing the kind of bugs that are really bad to have in commercial software because they can break when people are actually using it. To solve this problem, we can tell our array list to only accept information of a certain type. We do this by following our array list declaration and instantiation with these double character brackets and placing a type within them. In this case, we've declared and then caused to come into being an array list that will only allow strings to be stored within it. I guess I should now tell you what type of program we're going to write. I'd like to write a program that will take an input string from the user. It will store this input string and every other input string the user has ever given it, and then print them all out each time the user inputs a new string. This would be really difficult to do with an array because if the user ever inputted one more string than the array was designed to hold, our array would, best case scenario, not accept the string. Worst case scenario, our program might crash. But our array list object will simply resize to fit the number of strings that it's currently holding. So we're going to need a loop so that our user can input more than one string to the program. For now, let's just say while true. This is an infinite loop. It will run forever. But while we're building our program and debugging it, we can always just stop it manually. Each time our loop runs, we're going to want to use the next line function on our scanner variable to grab a new line of input from the user, which we're going to store in our array list. When we're working with object data structures, that is, data structures that have code wrapped around them and functions and methods of their own, we're generally not going to have to deal with the individual indices of memory, which can be pretty nice. Instead, we use their provided functions to add, remove, and manipulate the information within them. In this case, adding something to an array list is pretty easy. The .add function in an array list will add whatever input we give it, in our case, as long as it's a string, to the end of the array that the array list contains. So this line of code right here will request a new input string from the user and then put it on the end of our array list. Once we've done that, we can simply use println to print our array list out to the user. Println doesn't know how to take an array list as input. Actually, it might, but we should explicitly use the toString function, which almost every object in Java implements. Now, when we run our program, we'll get prompted for some user input, and we'll see that input echoed back out at us. If we give Java some more input, we'll see our new input and the old input has been stored in our array list. So that's pretty cool. Really basic program that would be more difficult to write with a simple array. Now, array lists have a lot of power contained within them. We can turn them into arrays, create them from arrays, and all sorts of things. And if we go to the Java documentation and check under java.util for array lists, we can find all of their methodologies. Let's add a couple more features to this program so that I can walk you through some common array list methods. Array lists have a function which takes no input called clear, which will erase our array list. We can utilize this function to give our users some control over our program. Let's say that if the user inputs the string clear, we would like to erase all of the information in our array list. Well, that's a conditional statement I just made, so we're probably going to want an if statement. We need to check the item just added to our memory variable, our array list, against the string clear. The item just added to our array list will be at the very end, the last item, the item with the highest index value. Unfortunately, there's no last item function implemented for array lists, but we can essentially create one ourselves by mashing together two array list functions. First, in order to get an item from an array list, we're going to usually utilize the get function. Get is very similar to the double brackets we would utilize if we were accessing an item from a traditional array. Get is going to take an integer value and it's going to map that integer to the index of the array contained within our array list. So, to get the last item in our array list, we need to know how many items are in the array list, and then we want to subtract 1 from that value, because the last index of an array with a length of, let's say, 7 would be 6, since the array starts counting at 0. To get how many items are in our array list, we can use the size function, which takes no arguments and simply gives us an integer that is the size of the array, how many items it contains. Once again, we want to subtract 1 from that value so that we're properly accessing the last index, not the index behind it, which could contain anything. And let's wrap that whole block in some parentheses. This block of code here is going to get for us a string. We know that we can compare strings by using the dot equals method. And we can actually call that method from the string object that this block of code returns, even though we haven't assigned it a specific variable name yet. Objects exist even if we don't have a name for them, and we can call their methods and do just about anything we like with them if we've just returned them from something else. So, that's a pretty crazy statement we've just written, but as long as we've written it right, when our user enters clear to the program, we will erase the array list. Once we've written this code once, we can write very similar code to give our user different functionality options. Let's also allow our user to type in end. Currently, because we're in a while true loop with no way of getting out, we're in an infinitely looping program until we manually turn it off. But by using the break Java keyword, which will jump us out of whatever loop we're in, or function if we're in a function, we can make this an escapable loop and let the user essentially turn off our program, because once we leave this loop, there's no more code to execute and our program will end. Be careful when you're using break statements. Make sure it makes sense to do so, because they can be a little confusing if you're going through someone's code and they're breaking and jumping the control flow all over the place. So let's run this program and see what happens. We'll start by giving our program some input and building up the array list. And now, oh no, I broke it. Okay, this is actually a pretty interesting error that we made. And I actually just made this error right now, recording this video. I'm going to leave it in because this is a great learning experience for us. It also shows you that even if you're an experienced programmer, you're going to make mistakes. One of the reasons that, for example, we should use typed array lists whenever we can, so that our mistakes are easier to figure out and fix. Back to the error at hand. Our program has thrown an array index out of bound exception. This means that we tried to access memory that our memory array did not have access to. Specifically, we tried to look at what was at index -1 of the array. Since arrays start at index 0, they don't have anything at index -1. Any piece of our computer's memory could be there, and programs aren't allowed to just go looking through a computer's memory because they want to, for security reasons. So, Why did this happen? Why did we ask for index -1 of an array, which is never going to be a valid array index? Well, this line of code executed just fine. Our program saw our clear command, understood our first look at our array index, and cleared the array. Immediately following that, we asked our program to check again for the last item added to our array. When we did this, we executed this bit of code right here. First, we asked Java, what size is our array list? Because we just cleared our array list, Java told us the size of your array list is 0. There's nothing in it. Then we subtracted 1 from that value to get -1. And we ran memory.get on that -1 value. Thus, we asked Java to take a look at what was at index -1 of our array. At which point Java said, whoa, 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 what are you doing? It's not cool. I'm going to crash. So, how do we solve this? Well, there's a couple things we could do. We should probably just check and make sure that our arrays are not empty before we run these functions. That looks like a few more lines of code than I want to put in this video. It's not undoable by any sense of the word, and I encourage you to try and implement a better solution than this yourself. For now, just to get our program quickly up and running without crashing, let's change our pair of if blocks to an if-else statement there we go, with another if statement embedded in the else. This will prevent us from ever running both of these lines of code back to back. If our clear statement executes, if this is true, then we will not check for the second if statement. Now if we run our program and give some gibberish input to build up our array list and type in clear, we're going to properly get the response of an empty array list. We'll never hit this statement with an array of size 0 because we're always going to add a line to our array just beforehand. Now, let's cross our fingers and check that the end program works. And, in fact, it does. The break command breaks specifically out of loops and functions. So, even though we've nested it within this if and else statement, it's still going to break us out of the while loop. So that wasn't quite as clean a look into array lists as I had expected it to be, but I think that little trip up we had was a great learning experience. That's actually a pretty interesting error we ran into. Nonetheless, I hope you've seen how different data structures have different purposes. As always, thanks for watching.